brighter star in the night sky. It has a name that I'm not going to be brave enough to try and pronounce, but you might. Apparently, it's become 50% brighter since the launch of the James Webb Space Telescope. It has transmitted numerous groundbreaking discoveries back to Earth, but its recent discovery is the most terrifying in the last decade. Betelgeuse, a volcanic giant star, has been reported to be on the verge of a devastating supernova explosion. The terrifying images captured by the James Webb Space Telescope have sparked widespread concern. Is our solar system under threat by this supernova explosion? Join us as we explore the potential impact of this explosion and what it means for Earth. On February 12, 1947, a large iron meteorite exploded in the atmosphere over the Allen Mountains in Russia. Eyewitnesses observed an explosive fireball erupting at an extremely shocking speed. According to a scientific report, the energy released by the explosion was estimated to be around 10 kilotons of TNT equivalent. Now fast forward to today, scientists are on their toes as the James Webb Space Telescope sends signals of the impending catastrophe, the supernova of Betelgeuse. For context, the potential energy of this supernova is approximately 2.5 x 10 circumflex 28 megatons of TNT equivalent. That's 2.5 decillion times the Allen meteorite event. For almost a decade now, Betelgeuse has captured the attention of scientists, but this recent shocking discovery has prompted experts to engage in intense research, studying ways the impending Betelgeuse supernova can potentially impact our dear planet. But to better understand this, let's explore another defining supernova event in the world of astronomy, the explosive end of a massive star known as supernova SN 1987A, which was observed in 1987. This powerful explosion released an incredible amount of energy, lighting up the night sky for days. It was one of the closest supernovas ever observed, and scientists have been eagerly studying it ever since. Located 168,000 light-years away in the Large Magellanic Cloud, a satellite galaxy of the Milky Way, this supernova has been the subject of intense study for experts. Astronomical observatories like NASA's Hubble and Spitzer space telescopes, as well as the Chandra X-ray Observatory, have previously studied it, but now the James Webb Space Telescope, JWST, has taken center stage, offering us the most detailed images of this iconic supernova. The JWST near-infrared camera, called NEOM, has captured breathtaking pictures that reveal the complex structure of the supernova. These images display its equatorial and outer rings, a crescent shape, an inner ejecta, and a peculiar keyhole structure. At the heart of the image are dense clusters of gas and dust, which are remnants of the stellar explosion. These clouds are so dense that even the powerful near-infrared light from the JWST cannot penetrate them, thereby creating a dark hole in the keyhole. Surrounding the inner keyhole, there is a luminous equatorial ring that formed from the debris ejected thousands of years before the supernova explosion. This ring also contains hotspots that glow brightly, formed when the shock wave from the supernova collided with the structure. Thanks to the JWST's sensitivity, scientists have discovered new crescent-shaped structures that are believed to be part of the outer layers of gas from the supernova explosion. One of the most intriguing aspects of this supernova is the elusive neutron star that was expected to have formed after the explosion. Finding it has been a challenge due to the dense core of the supernova. This explosion likely signifies the death of a blue supergiant star, one of the most massive and brilliant stars in the entire universe. As mysterious and captivating as SN 1987A was, scientists believe we might be on the verge of witnessing another mind-blowing cosmic event that could rival the supernova of SN 1987A. NASA astronomers are buzzing with anticipation since they got shocking news about Betelgeuse. It all started when something unexpected happened to Betelgeuse, a star known for its consistent brightness. Instead of gradually fading away like a star nearing the end of its life, it suddenly dimmed. This sudden change caught the attention of scientists and sent shockwaves through the entire scientific community. Using the powerful James Webb Space Telescope, JWST, astronomers made observations that confirmed the star's significant decrease in brightness within a short period. This raised serious concerns as experts tried to figure out an explanation. This is particularly alarming because Betelgeuse is no ordinary star. It's an absolute giant. Its diameter is a staggering 900 times larger than the Sun, and if we were to place it at the center of our solar system, its outer surface would extend far beyond the orbit of Jupiter. Massive stars like Betelgeuse have relatively short lifespans, and when they meet their cosmic end, it's explosive. These spectacular events, known as supernova, are not only fascinating to witness, but also play a vital role in the grand tapestry of the universe. During a supernova, elements such as carbon, nitrogen, and oxygen are scattered into space, which are crucial building blocks for life as we know it. Now, with the unexpected dimming of Betelgeuse, astronomers are anxiously waiting to see if this giant star is gearing up for an explosive finale. The possibility of witnessing another stellar spectacle, one that could surpass even the breathtaking SN 1987A, has everyone on the edge of their seats. But the Betelgeuse light we see is not as simple as the James Webb Space Telescope, JWST, presents it. When we look up at the night sky, we often overlook a crucial aspect linked to the nature of time and light in our vast cosmos. Due to immense distances, the light from distant stars and galaxies takes a significant amount of time to reach us. For instance, even though light travels at an astonishing speed of 186,187 miles per second, the distance we are looking at is 1,000 times farther than the distance between the Earth and the Sun. Therefore, the light we see from far-off celestial bodies has journeyed across vast expanses of space before reaching our eyes. So when we observe Betelgeuse, we are actually witnessing light that embarked on its journey 700 years ago. In other words, when this light began its long walk toward Earth, the Renaissance was just dawning, and explorers like Marco Polo were making their mark on history. Every observation of Betelgeuse is, in fact, a glimpse into the past. This means that if Betelgeuse had already exploded into a supernova, we wouldn't know about it for another 700 years. While we discuss and predict its imminent supernova, this monumental event may have already unfolded somewhere in the vast cosmos. All we can do is patiently await the arrival of light and the information it carries, traversing through the vast expanse of space and time until it finally reaches our telescopes. The secrets of Betelgeuse's fate lie hidden in the depths of the universe, waiting for their moment to be revealed. Is Betelgeuse fading away or preparing for a supernova? There are no straight answers to this question yet. Numerous theories have emerged in an attempt to explain this puzzling event. Some experts believe that dust clouds might be blocking Betelgeuse's light, causing it to appear dim. As the star ages, it sheds its outer layers, releasing dust and gas into space. This cosmic debris comes together to form dense clouds that obstruct the star's brightness. From our viewpoint, recent observations have shown that Betelgeuse is expelling more material, which could be contributing to the formation of these dust clouds. According to this theory, the sudden dimming of Betelgeuse is a natural part of the star's life cycle, especially for red supergiants like Betelgeuse. Another theory focuses on stellar pulsations. Massive stars like Betelgeuse often go through cycles of expanding and contracting. During the contraction phase, the star can temporarily dim. This rhythmic pulsation is common for stars like Betelgeuse. The star's immense gravity pulls its outer layers inward, causing contraction, while the heat from the core pushes those layers outward, leading to expansion. These fluctuations in brightness are a characteristic feature of red giant stars like Betelgeuse. So according to this theory, there is no cause for alarm. However, there's a more alarming theory gaining attention. Betelgeuse's dimming might be a sign of an impending supernova. Could we be on the brink of witnessing one of the most spectacular cosmic events in our neighborhood? Betelgeuse, being 20 times larger than our Sun, has always been destined to end its life in a cataclysmic supernova explosion. The sudden dimming could mean that the star is running out of fuel and approaching the point of collapse under its own gravity. Throughout history, stars that have dimmed suddenly have sometimes erupted into mind-blowing supernovae. Even before the supernova event, the James Webb Space Telescope, JWST, has been diligently observing Betelgeuse. Armed with advanced instruments like the near-infrared camera, the mid-infrared instrument, and the near-infrared spectrometer, The JWST has collected a wealth of data on this gigantic star. These instruments allow the telescope to take detailed pictures, study the star's light spectrum, and detect subtle changes in its brightness and temperature. For more context, let's take a minute to understand what Betelgeuse is. Betelgeuse is what we call a variable star. That means its brightness doesn't stay the same, but instead changes over time. While many stars show some fluctuations, Betelgeuse's variations are particularly noticeable and have been observed for over 100 years. Initially, scientists thought these changes were regular, but recent observations have revealed unpredictable changes, adding another layer of intrigue to this already enigmatic star. So what causes these fluctuations in Betelgeuse's brightness? Well, deep within its core, there are intense nuclear reactions happening like a bubbling cauldron. Hydrogen atoms fuse together to form helium, releasing a tremendous amount of energy in the process. This energy pushes the outer layers of the star outward, causing them to expand. As the outer layers of the star expand, they begin to cool down. This cooling effect causes the nuclear fusion rate to decrease. As a result, the star's brightness decreases, and the outer layers start to contract again. This cycle of expansion, cooling, and contraction continues in a repeating pattern, giving rise to the changes in brightness that we observe. Every time Betelgeuse pulsates, it provides astronomers with a glimpse into its internal workings. By studying these pulsations, scientists can learn about the star's structure, composition, and even its future. It's truly fascinating. Now let's talk about the color of stars. Have you ever wondered why some stars are blue, others are yellow, and some, like Betelgeuse, have a brilliant shade of red? Well, this is because the color of a star says a lot about its temperature. Blue stars are the hottest, with temperatures hitting 30,000 degrees Celsius. Next in line are yellow stars with an average temperature of 6,000 degrees Celsius. And then we have red stars like Betelgeuse, which are cooler, with temperatures around 3,500 degrees Celsius. So despite its red hue, Betelgeuse is still a relatively cool star. But don't be fooled by the term cool, because if you were to approach Betelgeuse, you would be incinerated long before you even get close. Now here's a more interesting fact about Betelgeuse: its age. It might seem paradoxical, but giant stars like Betelgeuse actually have shorter lifespans than smaller ones. This is because they burn through their nuclear fuel at a much faster rate. Considering the lifespan of Betelgeuse alongside recent events, scientists believe it is nearing the end of its life. And when it dies, it will do so in a spectacular way. It will explode as a supernova, unleashing an incredible amount of energy. The explosion will be so bright that it will be visible during the daytime and will outshine every other star in the night sky. When will the Betelgeuse supernova happen? And what are the effects on its surrounding environment? The exact moment a star goes supernova is a challenge to predict. However, the sudden dimming of the red giant has sparked speculation about the fate of Betelgeuse. Some experts believe that the end of this stellar giant may be closer than we think. One of the main reasons for this belief is Betelgeuse's age and its stage in the stellar life cycle. As mentioned earlier, massive stars like Betelgeuse burn through their nuclear fuel at an accelerated rate. Betelgeuse has already depleted the hydrogen in its core and has now moved on to burning heavier elements. Each phase of fusion that follows produces less energy and lasts for a shorter duration. As the star continues to fuse heavier elements, it forms an onion-like structure, with different layers burning different elements. However, once a massive star begins fusing iron in its core, it becomes a ticking time bomb. This is because iron fusion doesn't generate energy. Instead, it consumes it. This leads to a rapid collapse of the core, followed by a powerful shock wave that triggers a supernova explosion. Another reason for the belief that Betelgeuse may go supernova is its pronounced dimming. While dimming can be caused by various factors like dust clouds or stellar pulsations, the rapid and significant decrease in brightness could also be a sign that the star is nearing the end of its life. Before a star goes supernova, it may undergo a phase where it ejects a significant portion of its outer layers, resulting in these dimming events. The urgency to understand and anticipate the fate of Betelgeuse gets more intense by the day. Scientists and stargazers are captivated by the possibility of witnessing an extraordinary cosmic event. The explosion of a star like Betelgeuse has a dramatic impact on its surroundings. When Betelgeuse goes supernova, it unleashes an intense burst of light that outshines every star in the night sky for weeks or even months. The once familiar star becomes a radiant beacon visible even during the day. It's a breathtaking sight that captivates everyone who witnesses it. But the explosion doesn't stop in the dazzling light show. A powerful shockwave shoots through space, pushing and compressing the gas and dust scattered around. This creates a glowing bubble of ionized material called a supernova remnant that continues to shine for thousands of years. This remnant will serve as a lasting reminder of Betelgeuse's explosive end. As the explosion ripples outward, it releases a torrent of high-energy particles called cosmic rays. These particles travel at an incredible speed, with the possibility of reaching our solar system. While our planet's magnetic field and atmosphere protect us from its direct impact, they still have an effect. They interact with the solar wind and the charged particles emitted by the sun, creating enhanced auroras. These brilliant displays of light, usually seen near the poles, become visible in lower latitudes, captivating people around the world. The explosion also unleashes a tremendous amount of gamma radiation, the most powerful form of electromagnetic radiation. Gamma rays can create pairs of electrons and positrons when they interact with other particles. While most of this radiation gets absorbed by the surrounding gas and dust, some of it may reach our solar system. However, there's no need to worry, as Betelgeuse is far away and the radiation poses no direct threat to our planet. Instead, it adds to the background radiation that our satellites and space telescopes detect, giving scientists valuable information about high-energy processes in the universe. But the impact of Betelgeuse's explosion goes beyond the immediate surroundings. When the star explodes, it scatters heavy elements like carbon, oxygen, nitrogen, and precious metals such as gold and platinum into space. These elements become the building blocks for future stars, planets, and potentially even life. In a literal sense, our existence owes its existence to the death of stars like Betelgeuse. The carbon in our cells, the oxygen we breathe, and the iron in our blood were all synthesized in the hearts of stars that exploded long before our solar system came into existence. Studying the remnants of Betelgeuse's explosion will give scientists a treasure trove of information about the life cycle of massive stars. By examining the layers of material ejected during the supernova, they can piece together the star's history and understand stellar evolution, nucleosynthesis, and the dynamics of these explosive events. It's a fascinating journey into the mysteries of the universe. The explosion of Betelgeuse is a cosmic spectacle that demands our attention. It transforms the night sky, shapes the environment around it, and provides invaluable insights into the workings of the universe. It's a reminder of the immense power and beauty of the cosmos, urging us to explore and understand the wonders that lie beyond our world. Thanks for watching. Don't forget to hit the subscribe button for more interesting and informative videos.